with coordination among us, we were hello and welcome. Myself Shivesh Chaturvedi, and today I'm going to represent our project. So, so our topic of the project was production optimization by job shop scheduling, and these are my group members. With coordination among us, we were able to complete the project. Deepak Verma and Adarsh Kumar Agnihotri. So, talking about scheduling, scheduling is a general problem among manufacturing areas where the jobs require different time on different machines. So, arranging these tasks is a hectic job, and that's where AI comes in. And talking about the famous scheduling problem, we have timetable scheduling, job scheduling, and employee scheduling. So, our problem description is like that. Consider an industry where there are n jobs, and each job has to be processed on different machine according to a different schedule. So to reach to a final product, and the best example of it fits in a automobile industry where part of same machine has to be created by different manufacturers and then combined together. So consider this example where there is a product and it is made from three components: component one, component two, and component three. And here component one takes first goes on drilling machine, then milling, sorry, then drilling, then direct grinding machine, and then reaches to the final product. And talking about component three, it goes on grinding machine, then drilling, and then milling, and then to the final product. So each machine has got different number of jobs simultaneously, and thus to organize these tasks is the where JSP comes in. Talking about JJSP, yeah, a general way to formulate is like we are given n jobs J1, J2, and till Jn with varying processing time, which need to be scheduled on M machine with varying processing power, while making the make span minimum. And here make span means that total time required to produce the production output. Okay, and so while solving this problem, we had considered these constraints that the task no task for a job can be started until previous task of that job has completed. Like jobs are sequential orders, so we have to complete first one, then we will go to second task, and then a machine can only work on a single task at a time. And a task once started must run to completion. We cannot leave the task half in half. And we can see that these factors influence the job shop scheduling, like arrival pattern, which jobs arrive for job like different jobs arrive at different time. That is dynamic allocation, and then number of machines, work sequence that job task is scheduled on different machines. And it is the example that my friend Deepak will explain from.
So, hello everyone, I am Deepa Verma, second year undergraduate of the Department of Mechanical Engineering enrolled in its dual degree course, and I will be going to explain the code part of our project with considering a short example. So here comes the example. In example, we have some jobs and each job is inputted in a form of an array containing some tasks in a sequential order. And in each task we will be having two elements, I comma j, where I represents the machine number and the j represent the time taken to execute the task on that machine. And then like I will show an example like 0 comma 3. Here 0 represent the 0th machine and 3 represent the 3 unit of time is taken to complete the 0 task of the job 0, and each task will be done in a sequential order of each job. Now comes the output part. This is how our output part will look like, and in output part the y direction axis will be showing the index of the machine or the machine number, and the x direction will be showing the unit of time the job is done on that machine. Like is J1,0 representing the one job 1 of 0 task. Then let's move on to the code. So here comes our code. In coding part, we have the language used was Python, and we have worked on IDE PyCharm. Then for our code, we have installed a AuTools module for using some is useful for libraries to do some tasks. Firstly, we have done the input part of the jobs in a format of an array, and then we created some variables to remember some useful things like machine count and the horizon, which will be the total time of the jobs to be done. Then we have set some rules to do the tasks, and some constraints are also set by us, like the disjunctive constraint, which will check that no 2 or more jobs will simultaneously work on a single machine, and the precedent inside a job, which will be going to check that job whose executing time is less will be given preference uh, when we have 2 or more choices of work to be done on a single machine, like when we have task 0, 2 and task 0, 5, which will be going to be done on a 0th machine same time, but we will be giving preference to the first task like 0, 2 having the least minimum time. Then we will be showing the output in a format of an like this. I will show you like this. This will be our sample input 1 and sample output 1. The output will be look like this. Like this will be our machine numbers, and the right x-axis will be show the time taken by it, the start time and the end time of it. And we also recorded some statistics like conflicts and wall time, where conflicts represent the number of conflicts when we will be not be having the optimal answer, when we are finding some answers and we will not be able to find the solution. Then comes our wall time, which will represent the total time taken by the machine to execute the whole code. And here comes the final, which will be our required answer, the optimal scheduled time, which will be 11 here in our this case. And thank you. Now onwards, others will take over and explain you some key advantages of our project and conclude the project. Thank you.
Hello everyone, myself Adarsh, and now I will be talking about the important advantages of this project. Firstly, it helps us to provide us with more stable and structured planning of production processes. Secondly, it eases the data maintenance, and hence manufacturing companies can easily make informed decisions about job allocations based on data trends collected in the past. Also, its flexible nature helps us to easily update or integrate new effective solutions with the existing ones. And lastly, talking about the fourth advantage, its capability to provide real-time alert, error messages and notifications so as to keep in with rules and constraints will help us to make informed decision in real time as per the need of the user. Now I will talk about the plausible future advancements for this project, which can help us to make it more practical oriented and user friendly. So firstly, we can make our approach more dynamically oriented such that it becomes capable of handling input jobs, variable number of input jobs in real time. Secondly, use of GUI, that is graphical user interface, can be very beneficial. Such as an app or website can be developed providing the manufacturing companies with a GUI, graphical user interface, where the ongoing jobs and data can easily be tracked and hence by managed. And lastly, It can further be advanced by using a priority order for the some specific jobs on the basis of their need of urgency as per required by the user. It can be done by adding more number of constraints and rules, and then similarly we can update our algorithm according to it. So this conclude our project work. Thank you very much. And the more info about it can be will be provided by our project report. So once again, I thank you all.